Hello everyone and welcome back. Today in the continuation of previous lecture, we will continue mesh analysis with current source. Mesh analysis is a circuit analyzing technique. In this method, first of all, we find out number of meshes in the circuit. A mesh is a closed path which doesn't have any other loop in it. We assign mesh current and then we apply KVL to each mesh and transform voltages into mesh current form with the help of Ohm's law. After solving the equation, we find mesh currents through which we can find branch current and voltage drop across the various elements. In last lecture we started mesh analysis and we considered the circuits which were having voltage source only, which were either dependent or independent voltage source. Now in this lecture we will apply mesh analysis to the circuit which were having current source, which can be either dependent or independent. Applying mesh analysis to the circuits having current source may appear a bit complicated because in mesh analysis we apply KVL and for current source we don't know what will be the voltage drop in advance. But the presence of current source have benefits that it reduces number of equations. So let's start the mesh analysis with current source. For mesh analysis of a circuit with current source, we have two possibilities. We will start from case 1. The first possibility is that the current source, either dependent or independent, exists in a single mesh. Now if you look at the circuit have two meshes and two sources. One is voltage source and another is current source. And the current source is present in one of the mesh. Now we will assign mesh currents. Small I1 will be the mesh 1 current, where small I2 will be the mesh 2 current. Or we can simply say that in mesh 2 we have a 5 ampere current source, or mesh current I2 will be equal to minus 5 ampere because the direction of I2 is opposite to the current of independent current source. Now if you apply KVL on first mesh and transform voltages in the form of mesh currents, we will have the second equation. Now substituting the value of I2 in the KVL equation of mesh 1 and solving for the value of I1, we will have mesh current I1 equals 35/9 amperes. So whenever current source occurs in a single mesh and that current source is not shared by any other loop directly, so you can assign mesh current equals to the value of current source. But you have to be careful with the direction of current. If direction of current source and mesh current both are same, then mesh current will be equal to the positive value of the current source. But if both are opposite, then mesh current will be equal to the negative value of the current source. Like in this case, the mesh current I2 is equal to minus 5 ampere because the direction of mesh current is opposite to the current of the current source. Now the second possibility for current source is that it exists between two meshes or shared by two meshes. For better understanding, look at the example given in the figure. In this we have one voltage source with a value of 20 volt and two meshes, and we have a resistor in series with the current source of 6 ampere, and these are common between mesh 1 and mesh 2. Now to solve this, we will make a super mesh. Whenever two or more meshes in a circuit have independent or dependent current source in common, then we will use super mesh. And super mesh is created by excluding the current source and the elements connected in series with it. Now if you look at the figure A, in this we have two meshes and a current source in series with 2 ohm resistor. So for solving purpose we will make a super mesh by excluding 6 ampere current source and 2 ohm resistor from the circuit, and the resultant circuit will be like it will be like in figure B. Now the single mesh with current I1 and I2 represents super mesh. And super mesh is created because we apply KVL in mesh analysis, and KVL requires knowledge of voltages across the various element, where in case of current source, from specification we have the knowledge of current, but we don't know about voltage across the current source in advance. So the super mesh satisfy the KVL like other meshes. Now apply KVL on the super mesh. The equation will be minus 20 volt plus 6I1 plus 10I2 plus 4I2 equal 0. And on solving we will have 3I1 plus 7I2 equals 10. Also note down that 6 ohm resistor is a part of mesh 1, so current through this will be small I1, where 10 ohm resistor and 4 ohm resistor are part of mesh 2, so current through these resistors will be small I2. An important thing to remember is that if a circuit has two or more super meshes which intersects, so these all super meshes will be combined to form a single larger super mesh. Now in the given circuit we have two unknown mesh currents I1 and I2, and we have one equation, and for solving two equations are required. Now for the second equation we will use KCL at node 0. At node 0 we have current I2 entering, where 6 ampere current and I1 are leaving currents. So the KCL equation will be I2 equals 6 ampere plus I1. Now solving equation A and equation B give us the value of mesh currents, which are I1 equals minus 3.2 ampere, where I2 equals 2.8 amperes. Now in the given example, you have to find mesh currents I1 to I4 with the help of mesh analysis. If you look at the figure, in this circuit we have 4 meshes, and we will assign mesh current to each of them. And these mesh currents will be I1, I2, I3 and 4, and we will also define their directions, which is clockwise as usual. Now if you look at the circuit, we have two current sources. One is independent current source of 5 ampere, where another one is dependent current source with value of 3I0. And I0 is the current leaving from the independent voltage source and in opposite direction of mesh current I4. Now apparently we have two current sources common between three loops, so which results in two super meshes. But as we have studied, we will try to make a single larger super mesh. Like mesh 1 and mesh 2 have independent current source of 5 ampere, where mesh 2 and mesh 3 have a dependent current source of 3I0 ampere. As these super meshes are intersecting, so they will form a single super mesh. Now as a part of step 3 in mesh analysis, we have removed the current sources, both dependent and independent, and by combining super mesh 1 and super mesh 2, we have formed a single larger mesh. Now we will apply KVL to this larger super mesh, which results in the equation 2I1 plus 4I3 plus 8 into I3 minus I4 plus 6I2 equals 0. Or on simplifying, I1 plus 3I2 plus 6I3 minus 4I4 equal 0. Again note down that 2 ohm resistor is a part of mesh 1, so its current will be I1. 6 ohm resistor is a part of mesh 2, so its current will be I2, and 4 ohm resistor is a part of mesh 3, so its current will be I3, where 8 ohm resistor is common between mesh 3 and mesh 4, so its current will be difference of I3 and I4. And this will be the first equation of the circuit. Now we will apply KVL in mesh 4, which will give us second equation of 5I4 minus 4I3 equal minus 5 volts. And this will be the second equation for the circuit. Now so far we have two equations and 4 unknown variable, and 2 more equations are required. So in the hunt of another 2 equations, we will use KCL. At first we will apply KCL to node P. At node P, I1 and 5 ampere currents are leaving from the node, where I2 current is entering into the node. And this will give us equation of I2 equals 5 plus I1. Now we will apply KCL to node Q. At node Q, 3I0 plus I3 currents are entering into the node, where I2 is leaving from the node. And we know that I0 is equal to minus I4 because they are opposite in the direction. Now substituting the value of I0, we will have the last equation of the circuit, which will be I2 equals I3 minus 3I4. Now on solving equation A, B, C and D for unknown mesh currents, we will have the following results. I1 equals minus 7.5 amperes, I2 equal minus 2.5 ampere, I3 equals 3.93 ampere and I4 equals 2.143 amperes. Now we will discuss few properties of supermesh. The first one is that current source in the supermesh provides the constraint equation which is required for the solving of mesh currents. And also the supermesh have no currents of its own. And for solving we use predefined mesh currents. And the supermesh requires the application of both KVL and KCL, like we were using in the case of supernode. And thanks for watching this video.